Hello everyone, welcome back again to Exclusive Tutorial. My name is Dr. Flash, and we're having a problem on the board, the TVD problem. Okay, the real picture will be uploaded on the side of the screen, so do it to screenshot it if you need it, and that is if you can't see this diagram clearly. Now in this case, we're having two forces, F1 and F2, and F2 is having an angle of 45 degrees to this plane, and 30 degrees this plane is making with the x-axis, and so on and so forth. So we'll be solving this problem. The problem wants us to determine the resultant force acting on the hoop. Okay, the resultant force, that is a single force in which we'll place it on one part of this hook, it will have the same net effect as these two forces acting. Okay, now to do that, we first of all have to resolve F2 and F1 to the various components. So for F2, we are going to be starting on F2. So for F2, okay, so for F2 now, we first of all have to determine the value of F prime, that is the force on this plane. Okay, so F prime will be equal to resolving this force F2 to this plane. It will be F2, okay, F2, we are closing the angle, so we get cosine of 45 degrees. Okay, and F2 has a value of 800 pounds, so that will be 800 cosine of 45 degrees. Now solving that 800 cosine of 45, what do we get? 800 cosine of 45 degrees, we get a value of 565.69. we get a value of 565.69 pounds. That's the value of F prime. Now this F prime is now the force on this plane. We're going to resolve to the x and to the y axis, and to get the one for the x, it will equal F prime resolving to the x as we are placing the angle, so we get cosine of 30 degrees, and that will equal 565.9 cosine of 30 degrees. Now f of x will then give us a value of the answer multiplied by cosine of 30 degrees. That gives us 489.90 to two decimal places. That gives us 489.90 pounds to two decimal places. And then for the y-axis, we are going to be opening this angle or determine the value of the angle here, which is 60 degrees, because of course x and y components are always perpendicular, so 90 minus 30 gives us 60. Now for the y components, we are going to have the force which is on this plane, which we obtained as F prime, and we're opening it, we are using the angle 30, so it's sine. We are going to be having F prime sine of 30 degrees, and that will equal 565.9 rather times the sine of 30 degrees. Okay, so I'm multiplying F prime by the sine of 30 degrees. That gives us a value of 282.84. okay, that will give us 282.84 pounds to two decimal places. Now next we want to do is obtain the value of f of z. To obtain f of z, that is the force acting on the z component due to this F2, we are having this force at an angle of 45 degrees already, okay, to this plane. That's the angle 45 degrees. So what we want to do is open it into the page. Okay, we're having something like this z component, we're having a normal plane like this, and then we're having some force like this, and the angle is 45 degrees. We want to open it into this negative z component, so we're going to make use of what now? Sine. Opening into the negative z component, but we'll get a value of negative we'll be having a negative z because we are resolving to the negative z components, so that will give us a value of minus 800 pounds times the sine of 45 degrees. Now in this case, sine is actually applicable, okay, because sine is the correct one. If we make use of cosine, we get the same answer, because cosine of 45 degrees and sine of 45 degrees give the same answer. But in this case, we make use of sine of 45 degrees because that's the right one to use. You are opening the angle. Now minus 800 cosine of 45 degrees minus 800 sine of 45 degrees rather, sine of 45 degrees gives us the value of minus 565.69. okay, approximately minus 565.69 pounds. Now these are the values for F2, so I can write F2 as the sum of these guys in Cartesian form. So F2 will equal 489.90 pounds. Okay, no need for the pounds, so just write it in Cartesian form, that is in terms of I, and then for the y-axis we get plus 282.84 j, and then we have minus 565.69k. This is the value of f2. Okay, we're not done, we just only resolve the values of f2. Let's now resolve for f1. Now for that of f1, we'll simply resolve. In this case, we are not having a component for the f1 on the x-axis. You see, we are just having the force between the y and the z component. So we can say for the f1, f of x is equal to 0, or we can say 0i, anyone you want, okay, or 0 pounds. Now let's now get the one for the y-axis. For the y-axis, f of y. Now you probably haven't seen a small triangle using denoting directions for vectors before. Okay, now I'll be talking about this in a separate video, but for this question, let's just tackle this problem using this triangle like that. Now the triangle, I'm going to bring it out here, and this is what we're going to have when I bring it out. We'll be having an angle theta here, makes 5, 3, and 4. Now to get that angle, we make use of cosine, sine, or tan. Okay, we would make use of the tan inverse of 3 over 4, which is opposite of adjacent, and then cosine inverse, that is 4 over 5, or sine inverse 3 over 5. You get a value for theta. Okay, but if you are doing that, you are only stressing yourself, and it will help you to you get the same answer, but it's actually time wasted. Okay, so our students will not actually do that. Just solve with the triangle directly and see how we're going to do it. Now the angle here is theta is the value of the force made with the y-axis because of the position we're having the triangle. Assuming the triangle was on top, we'll be having the angle with the z-axis. Now for f of y, while resolving it to the y-axis, we are going to get 500. Resolving this means we are closing, that is cosine, and cosine is what now? Adjacent to our hypotenuse, that gives us 4 over 5. 4 over 5 gives us a value of 400 pounds. Okay, 500 times 4 divided by 5. Now for f of z, to get the value of f of z, we are resolving to the z component. That becomes sine, which is the opposite of 4 over 5. Of course, we can see the diagram that is 3 over 5. That gives us a value of 500 times 3 over 5, which gives us 300 pounds. Okay, now so we can now say that f of 1 is 0i plus 400j plus 300k. Now this is value of what now? f1. To now get the total the resultant force, remember I said to get the resultant force, whenever you're having component forces, we simply take the sum of the individual forces. Okay, we sum the one for the I component, the j, and the k component. So we're going to write the resultant force here. The resultant force will be equal to, now for f1, okay, first of all we know it's f1, not f2. So for f1, we're having 0i, and we're going to sum it with 489.90j. That gives us a value of 489.90i. okay, and then for the j-axis, we're having 400 plus this guy. That will give us a value of 682 rather. I think we'll get 682 if I'm not mistaken. 682.84j. And then for the k axis, 300. I'm going to make the calculation for this one. We're having minus 300 minus 565.69. that goes to the value of minus 265.69. that will give us minus 269.69. okay, minus 269.69k. now that's the value of k in this resultant vector. So here we have the resultant vector to be 489 in the x-axis, and then 682 plus 0.84 minus 269 points, what you're seeing on the board, okay, for the value of k. Now what we're having here is the resultant force in terms of quadrature form. To find the next one, that is the magnitude, you can simply take the square root of the sum of individual of the squares of all these values we're having on the board. If you don't know how to compute these values, you can watch our previous video on vectors on how to do this. And then the question did not require us to solve a derivation, but if you want to find derivation, first of all you have to find the magnitude, then find the unit vector, and then equate cosine of alpha to get the angle to the x-axis, cosine of beta equate it to get the angle of the y-axis, and cosine of gamma equate the angle to get the angle on the k-axis or the z-axis. Now that is all for today. In our future videos we'll be solving more engineering problems on MS Flash. If you have a question, do it to put it in the comment section, do it to like, share and subscribe. Okay, I advise to share these videos with your friends. Do not let it known. In our future videos we'll solve more questions like I said initially. Stay tuned to Exclusive Tutorial. God bless you.